You have seen light your entire life. It fills your room in the morning, it bounces off your phone screen, it lets you read these words right now. It feels ordinary, constant, almost invisible in its familiarity. But light is not a smooth stream, not really. At its most fundamental level, what you are seeing right now is made of tiny, discrete packets. Each one is called a photon, a single photon. You have never seen just one, not with your eyes. There are always too many, arriving together, overlapping, flooding your vision. But they can be counted, measured, even detected one at a time in controlled experiments, and each photon is the smallest possible unit of light. It has no size in the way you imagine objects having size. No tiny glowing sphere drifting through space. It behaves like a particle sometimes, like a wave at other times. It does not sit neatly inside your intuition. Still, it is real. Right now, trillions of photons are striking your eyes every second, from your screen, from the room around you, from reflections bouncing off walls and objects. You don't notice them individually, you never could. But imagine for a moment that you could. Imagine sitting in complete darkness, absolute darkness, no ambient glow, no distant light leaking in. Then suddenly, one photon arrives, just one. No glow, no beam, no brightness filling the room, just a single silent event. A tiny interaction inside your eye. A molecule changes shape. A signal begins. Your brain registers something. Not an image, not even a clear flash, just the smallest possible hint that something happened. That is how little light you need for reality to begin. And yet, that single photon may have traveled farther than anything you have ever known. It may have crossed empty space for years, or centuries, or billions of years. It may have started its journey before Earth existed, before the sun was even formed, before there were planets, oceans, or life. One photon, and it reaches you. This is where things begin to shift, because once you stop thinking of light as something continuous and start thinking of it as individual travelers, each with its own story, the universe changes. Every beam of light becomes a history. Every flicker becomes a message. Every point of brightness becomes a distance. You are no longer just seeing things as they are. You are seeing where they were, and sometimes, how long ago they existed. The light from your screen takes a fraction of a second to reach you, so small you cannot feel it. But light from the moon takes about 1 second. From the sun, 8 minutes. From the nearest star beyond the sun, over 4 years. Already the idea stretches, but this is still close, still local, still inside a tiny neighborhood compared to what lies beyond. Because most photons do not come from nearby. Most of the light that reaches Earth has traveled across distances so vast that human language struggles to describe them. Distances where time itself becomes part of the journey, and once you follow even a single photon far enough, you begin to realize something unsettling. You are not just looking at space, you are looking into the past. And the farther that photon has traveled, the older the story it carries. I know, so the question is no longer just what light is. The question becomes, how far can one photon go before it finally arrives here? You are standing on Earth. It feels large, solid, complete. If you tried to walk across it, it would take months. To fly around it takes hours. It feels like a world that contains everything you know. But light does not experience the world this way. A photon leaving the surface of Earth could circle the planet more than 7 times in a single second. 7 times, in the time it takes you to blink. Already your sense of scale begins to slip. Now imagine that photon leaving Earth entirely. It moves outward, past the thin atmosphere, past satellites, past the orbit of the Moon. In just over 1 second, it reaches the Moon's distance, about 384,000 kilometers away. To a human, that distance is enormous. The Apollo missions took days to travel it. To a photon, it is barely a moment. Keep going. The photon continues outward into the vast space between planets. It crosses the orbit of Mars in minutes. It passes Jupiter in less than an hour. Jupiter is so large that more than 1,300 Earths could fit inside it. And yet to this photon, Jupiter is just something it passes along the way. No resistance, no delay, just motion. After about 5 hours, the photon reaches the edge of the solar system's main planetary region. Beyond this, the sun's influence begins to fade into a thin, distant boundary called the heliosphere. It is not a sharp edge, more like a gradual thinning of the sun's reach. Even here, the photon does not stop. It keeps going. After about 17 hours, it reaches the distance of Pluto's orbit. 17 hours! That is how long light takes to cross what we once thought was the entire solar system. And yet this is still nothing. Because beyond Pluto lies a vast region of icy debris known as the Kuiper Belt, and far beyond that, an even larger spherical cloud of objects called the Oort cloud. The Oort cloud extends up to 100,000 times farther from the Sun than Earth does. If a photon travels from the Sun to Earth in 8 minutes, then reaching the outer edge of the Oort cloud could take more than a full year, of uninterrupted travel at the fastest speed possible in the universe. And still, the photon has not reached another star. That is the first real shift. Because the space between stars is not just large, it is empty in a way that feels almost absolute. The nearest star system, Proxima Centauri, is about 4.24 light-years away. That means a photon leaving Earth today would take over 4 years to arrive there. 4 years of silence, 4 years of nothing to interact with, just empty space. Now imagine that photon continuing past Proxima Centauri deeper into the galaxy. Our galaxy, the Milky Way, contains hundreds of billions of stars. If you could travel at the speed of light from one side to the other, it would take about 100,000 years. 100,000 years. That is longer than human civilization has existed. And yet photons make this journey constantly. Crossing the galaxy from one edge to another, carrying information about distant stars, supernova explosions, and clouds of gas forming new suns. Some of the light you see in the night sky began its journey long before humans learned to write, before cities, before agriculture. You are seeing ancient events, but even the Milky Way is not the limit. It is just one galaxy among many. Our nearest large galactic neighbor, the Andromeda Galaxy, is about 2.5 million light-years away. That means the light reaching your eyes from Andromeda tonight began its journey 2.5 million years ago. When that photon started moving toward you, early humans did not yet exist. On Earth, small, primitive ancestors were just beginning to walk upright. Everything you are happened after that photon left. That is the gut punch. You are not just looking far away, you are looking back before yourself. And still, the photon continues, because beyond Andromeda are trillions of other galaxies, each one filled with stars, planets, possibly life. On the observable universe, the part we can see, extends about 46 billion light-years in every direction. Not because it is that old, but because space itself has expanded while the light was traveling. So a photon emitted shortly after the universe began has been traveling for over 13 billion years. And during that time, the space it moves through has stretched. So the distance it has covered is far greater than 13 billion light-years. It is closer to 46 billion. Try to hold that number. You can't. No one really can. But the photon doesn't care. It just keeps moving. And some of those photons are still arriving. Right now. They are called cosmic microwave background radiation, the oldest light we can detect. They were released when the universe was only about 380,000 years old, before stars, before galaxies, before structure, just a hot, dense fog slowly cooling. Those photons have been traveling ever since, for over 13.8 billion years, and now they are reaching Earth, reaching you, passing through your body, your room, your planet, mostly unnoticed, silent, ancient, untouched. So here is the question that begins to form. If a single photon can travel across the entire history of the universe, what does that say about where you are in that journey? You are sitting in a room, or standing, or lying down. There is light around you, It feels immediate, present, yours, but it isn't. Not entirely. Every photon that reaches you is a messenger. Some traveled fractions of a second. Others traveled years. Some traveled longer than human history. A few have been moving since before the Earth existed, and they all end the same way. They arrive. Here, now, inside your eyes. That is where their journey stops, and that means something strange, because it means you are part of the universe's endpoint for those photons. After traveling unimaginable distances through complete darkness across expanding space, they meet you, a chemical reaction, a signal in your brain. And then, nothing. Their journey is over. In a universe that is vast beyond comprehension, you are one of the places where things finally happen, where motion becomes meaning, where energy becomes experience. It is easy to feel small when thinking about the scale of the universe, and you are small. Smaller than planets, smaller than stars, smaller than galaxies. Your entire life unfolds on a thin layer of a single world, orbiting one star among hundreds of billions, and yet you are not irrelevant. Because scale is not the same as importance, the universe does not assign meaning based on size. It simply exists, cold, expanding, silent. Photons cross it endlessly, carrying information without purpose. They do not choose where they go. They do not care where they end. But when they reach you, something changes. For a brief moment, the universe is observed, felt, known. A photon that left a distant galaxy millions of years ago does not know it has arrived, but you do. You turn your head, you look up, you see a faint point of light, and in that moment you connect with something that existed long before you. That is not something the universe does on its own. That is something that happens because you are here, because you can notice, because you can ask questions. Because you can follow a single photon backward in your mind, across space and time, and realize how far it has come, and how unlikely it is that it ended here, with you. There is no guarantee in the universe that anything should be seen. Most of space is empty. Most photons never encounter anything at all. They pass through darkness forever. No eyes, no surfaces, no reactions, just endless travel. But some do arrive. Some reach planets, some reach life, some reach minds capable of understanding what they are. That is rare, extraordinarily rare. And you are part of that rarity. You are not just in the universe, you are one of the few places where the universe becomes aware of itself. Not in a mystical way, not in a grand designed sense, but in a simple, physical, undeniable way. Light arrives, and it is seen. That is enough. So when you look at the world around you, or up at the night sky, you are not just seeing light, you are witnessing journeys that began long before you and will end the moment they reach you. And in that quiet exchange between a photon and your eye, something vast becomes personal, something ancient becomes immediate, something incomprehensible becomes just barely understood, and then it is gone, replaced by the next photon, and the next, and the next. A constant stream of endings, arriving here in silence, in the dark, with you.